All right, we're talking about parallelograms. Let's review just briefly, because actually today's lesson works out really well that we've had the break from parallelograms, but today's lesson has a lot to do with these rules for parallelograms. Because remember, when we said, if this thing was a parallelogram, if I said that this right here was a parallelogram, I'm not even going to label it, but if this was a parallelogram, what was true about it? If I said this thing was a parallelogram, by definition, what could I say about these opposite sides right here? That they were what? By definition. That they were what? They were parallel. That's right. Okay, so this side and this side would be parallel, and this one would be parallel. We also said, not by definition, but now we had some theorems. What's true about these two sides if it's a parallelogram? They're equal to each other. That's right. The opposite sides are equal to each other. Then we said something about the opposite angles. This angle up here at the top left and this one down here at the bottom right. What did we say about those two? They got to be equal to each other, right? So if these two are equal and if this is a parallelogram, then these two are equal and these two are equal. Everybody got that? Pretty easy. Then, I'll just draw these in here. Then we talked about the diagonals, didn't we? You remember what we said about the diagonals of a parallelogram? They bisect each other. That's right. A lot of people mistakenly say that they're equal to each other, but they are not equal to each other on every single parallelogram. Later on this week, we're going to talk about a situation where the diagonals are equal to each other, but not on just any regular normal parallelogram. Okay, they are not equal to each other, but they do bisect each other, which means this segment right here is equal to this segment right here. Do you see it? Okay, they bisect each other, so that means they're both split in half. So this little segment, this little chunk, let's just mark it. This little chunk and this little chunk are equal, and this little piece right here and this one right here are equal to each other. Everybody got that? And was there anything else that we said about this? I think, if I remember right, I think that's it. Okay. We okay with that? Is it coming back to you now? Right? It's not like we've been gone a whole, summer break. It's only been 2 weeks, but I know what it's like. 2 weeks is still 2 weeks. Let's do this now. Let's talk about this thing, this parallelogram. But let's say we don't know it's a parallelogram. I'm gonna make it real big. Okay. Let's say we don't know that this is a parallelogram, but we do know a few things about it. Let me scooch this over just a little bit more, just to give myself some room to write. Let's just say this was just a four-sided figure, a quadrilateral, and we wanted to show that it was a parallelogram. Remember how we did the converse? We've done that all year, haven't we? We give a statement, if this is true, then this is true. If it's a parallelogram, then the opposite sides are equal, right? You guys paying attention? Okay, up here. Let's look up here. Thank you. We said, if it's a parallelogram, then all this stuff is true. The opposite sides are equal, the opposite angles equal, all that kind of stuff. If it's a parallelogram, then all that stuff's true. Guess what we're going to do now? We're going to switch it around and say, if what? What do you think? If the sides are equal, right. If the opposite sides are equal to each other, then guess what kind of figure this thing is? Then it's a parallelogram. You follow me on that? All right, so let's do this. Let's just make this another color here. What if I told you that, and let's label it, might as well, so that I don't just say this and this all the time. So A, B, C, D. So what if I said that AB is equal to DC? Now, if that's all I knew, could I say that that's a parallelogram? If I just knew that these two opposite sides are equal? No. I got to know what? Both pairs, right. The other sides too. I got to know both pairs of opposite sides are equal. So watch, here's the deal. If, I'll just say this. I'm going to shorthand it a little bit, but I'll throw some things, I'll say some things in here. If the opposite sides are equal, then guess what this whole thing is? Guess what ABCD is? It's a parallelogram, exactly right. Okay, so if the opposite sides are equal, that means if AB equals DC and if AD equals BC, if those two things are true, both of those things have to be true. You can't just have one set of sides equal to each other. Both, all right? If both pairs of opposite sides, if you want to write that in there just to make sure, if both pairs of opposite sides are equal to each other, then guess what it is? That's an ugly looking parallelogram. Let me try that again. I got to get used to writing on this thing again. It's been a couple weeks. All right. You probably think I just sat home all break just doing geometry on this thing just for fun, didn't you? Okay, but but I haven't. Actually, didn't do much during the break, and that's what I wanted to do. Not much. I just wanted to just relax a little bit, and that's what I did. Yeah, that wasn't very relaxing last night, though. But but I did watch it last night. So if both pairs of opposite sides are equal, then it's a parallelogram. Now, if it's a parallelogram, what must be true about it? We've established now, just by these opposite sides being equal to each other, it's a parallelogram. So what could I say then? I could say this big angle A is equal to what? Angle C, because I've established now that it's a parallelogram, haven't I? Make sense? All right. And I could also say that this big angle D is equal to this big angle B right here. Right? And I could say that the diagonals bisect each other. I could say all that stuff now. I could say that the opposite sides are parallel to each other, because now I know it's a parallelogram. All right? So that's all I had to show. I had to show that the opposite sides are equal to each other. All right? We good with that? Let me get rid of these, just so we don't get too much junk all over the place here. Okay. That's the first thing, and that's a theorem. They call it theorem 6.9. Okay, 6.9, but I don't care that you know the numbers of the theorems. We just say that if the opposite sides are equal, then it's a parallelogram. It's a converse of what we said before. Well, what did we say before? If it's a parallelogram, then the opposite sides are equal. That's right. But now what are we saying? We're saying if the opposite sides are equal, then guess what? It's a parallelogram. Do you see the difference? All right, so we took the regular statement, we took the converse of it, we switched the if and the then, and we've got a theorem on its own. All right, what else do you think might be true? I'll tell you what, let's do this. Let's get rid of these diagonals. Travis. Good, let's go in that order. Okay, so let me make this red. Right, so we have another one that says if the opposite, oops, let me put the opposite. Now, again, I just don't have a whole lot of room here to write, but if you want to say if both pairs of opposite side or angles are equal, okay? I'm just saying if opposite angles are equal, but if both pairs of opposite angles are equal, then what's this four-sided figure? What's this quadrilateral? It would be a parallelogram. Okay? So if both pairs of opposite sides are equal, what does that mean? If angle A equals angle C. Now, is that enough right there to say that that's a parallelogram? No, it's not. Okay, you can't just have one pair of opposite sides. You have to have what? Both, right. Two pair of opposite sides. Okay, both pairs of opposite sides. I keep saying sides. What do I need to say? Angles, right. If both pairs of opposite angles are equal to each other, then guess what this whole thing is? Then it's a what? Parallelogram. Now I can say, I didn't know at first. Remember, I didn't know at first that this was a parallelogram, but somehow they told me that A and C were equal and B and D were equal, so that means that this thing is now a parallelogram. So if it's a parallelogram, what could I say? Just with that information given, what could I say about A, B, and D, C? What do you think, Ben? Tell me. A, B, and D, C? Line segments, A, B, and D, C. Okay, they're parallel. They're what else? They're congruent, right? They're equal to each other, right? What else could you say? You could say that AD and what? BC are equal to each other and also what? Parallel to each other, right? Just by knowing that the opposite angles are equal, I could tell all that other stuff. If I had some diagonals in here, what could I say about those diagonals? They do what? They bisect each other. Very good. Make sense? All right. Just by knowing that information right there, I could say all that other stuff, because this information tells me that this is a parallelogram. If it's a parallelogram, then all that other stuff's got to be true too. Make sense? All coming back to you now? This is kind of a good review lesson. It just kind of worked out that way, but it's kind of good that we have that. All right, let's do another one. Let me get rid of these angle symbol things. All right, and let's put those diagonals in there. Put one right there, and hello. We'll put one right there. All right, so now we got some diagonals. So what would your next guess be? If the what? Follow the pattern. We said if the opposite sides were equal, then it was a parallelogram. If the opposite angles were equal, both pairs of opposite angles were equal, then it was a parallelogram. What do you think we can say about that? If the, well, we're talking diagonals now. If the diagonals do what to each other? Bisect each other, that's right. So if the diagonals bisect each other, so if the diagonals, I'll just shorthand that, bisect each other, all right, I just don't have room here. If the diagonals bisect each other, then guess what this thing is? Yeah. Right? You're getting into the rhythm now, aren't you? All right, so if the diagonals bisect each other, what does that mean? Let's call this P. Let's say that AP and PC are equal to each other. Let's say DP and PB are equal to each other. If that's what they told us, they didn't tell me anything else. They didn't tell me this was a parallelogram. They just said, here's a four-sided figure. These are diagonals right here. AC is a diagonal and DB is a diagonal. If they bisect each other, if this segment and this segment are equal, and this one right here and this one right here are equal to each other, if those things are true, guess what this whole thing is? Guess what ABCD is? It's a parallelogram. Now, if it's a parallelogram, what do I know? What else do I know about it? I know the opposite sides are equal. I know the opposite sides are also, I already said equal, parallel to each other, right? Okay, the opposite sides would be parallel to each other. What do we know about the opposite angles now? We know they're equal to each other, right? So just because we know this stuff right here, there's other stuff about this that we know because it's a parallelogram. Making sense? All right, this early in the morning after a break, everybody thinking? All right. All right, so there you go. So we know about that. We got one more to do. Let's get rid of these things right here. Okay. Let's get rid of my diagonals. I don't need these now for what we're going to do here. All right, here's one that may not be quite as easy to see. Do you remember at the very beginning I said if this and this were equal to each other, does that make that alone, if that's the only thing I knew, does that make that thing a parallelogram? No, it doesn't. I would have to show both pairs of opposite sides equal, wouldn't I? But there's also something else, though. This is something that you may not have thought about. But if I show this one pair of opposite sides equal to each other and parallel to each other, do you see that? I picked one pair of opposite sides. I could have picked these two if I wanted to, but I just picked one pair of opposite sides. If I could show that two things are true about it, if I could show that they're both equal to each other in length and parallel to each other, do I know that this and this are parallel? No. I just know that this one and this one are parallel. If I know, and so how would I want to say it? If one pair of opposite sides, I'll write this whole thing out, are what? Are equal and, not congruent, and parallel, then guess what's true about this thing? Then it's a parallelogram. Okay? That's a little different than what we had before. So if I can just show that one pair of opposite sides are both equal to each other and parallel to each other, that's enough to say that this thing is a parallelogram. Okay? So on all of these, you had to show two things, didn't you? On the first one, you had to show two opposite sides equal to each other. Then you had to show two pairs of opposite angles equal to each other. So that's two things. On the diagonals, you had to show that both diagonals were bisected. Okay, that was two things. On this one, you got to show two things as well. You have to show that this one pair of sides is equal to each other and parallel to each other. That must mean that this thing is a parallelogram. ABCD is a parallelogram. Is that making a little bit of sense? Yeah, I think so. That's not too hard to figure out, is it? All right, let's do an example real quick. We'll do a couple of them. We got some time. And let's get rid of all this. Let's put a parallelogram up here again. And I'll do the first example that they do. This is straight from the book, so if you wanted to look in the book for this, feel free. Why do I keep doing that? See, if I have that straight line tool and I just touch it once, watch. See, it does that. That's why it makes that noise. Okay, here we go. Let's label it just the way they do in the book. F, G, H, J, and this middle one is K. Alright, there we go. We don't know anything about it. I don't know that it's a parallelogram, okay? All I know is it's a quadrilateral, four-sided figure, and I've got a couple diagonals in here. Okay, that's all I know. Everybody with me on that? Alright, so here's something else that they tell you. They tell you that FK, they tell you right in the problem, that FK is 3x minus 1. They tell you that KG is 4y plus 3. JK, 6y minus 2. And let's see, KH, 2x plus 3. Alright, and we want to solve for x and y. Now, the problem says, find what x and y is so that this thing is a parallelogram. So find x and y to make this thing a parallelogram. So let's see what they give you here. FK is from here to here, and that's 3x minus 1. Alright, so I'll put that right there. KG is 4y, KG, this one right here, it's 4y plus 3. Let's put that right there. JK is 6y minus 2, so I'll put that right here. And then KH is 2x plus 3. Alright? Now, in order to make this thing, in order to say that this is a parallelogram, what must be true about these two segments right here? What do you think? They got to be equal to each other, right? Does that make sense? Alright? The math is not hard, okay? The math really, in this whole entire course, has the math really been that difficult at all? The algebra? No, it's been pretty basic Algebra 1 kind of stuff. Okay, it's putting it together, knowing what is equal to what adds up to what. So that's the geometry part. So look, in order to make this thing a parallelogram, these diagonals must bisect each other, correct? Because if the diagonals bisect each other, that makes this thing into a parallelogram. So that means that FK and HK must be equal to each other. So let's set them equal to each other. 3x minus 1 must equal 2x plus 3 in order to make this thing into a parallelogram. So let's do the math real quick. Subtract 2x from both sides, that's an x. Add a 1 to both sides, that's a 4. And there you go. So x is equal to 4. It just says solve for x and y. It doesn't say find the lengths of the segments. I could very easily, though, couldn't I, on a quiz or a test, ask you to solve for the length of FK or something like that? Yeah. And that wouldn't be hard, would it? You just plug it in, right? See what it is. Let's just do that for fun. 3 times 4 is 12, minus 1 is 11. They're both 11, right? Let's see if this works. 2 times 4 is 8, plus 3. Yep, they're both 11. Alright, good deal. Let's solve for y now. This is no more difficult, is it? These two segments right here must be equal to each other because if the diagonals bisect each other, then the thing must be a parallelogram. So 6y minus 2 must equal 4y plus 3. This is way too easy, isn't it? Subtract 4y from both sides, add a 2 to both sides, that's a 5, and then divide by 2. It's 5 over 2 or 2.5. Or 2.5, however you want to write it, it doesn't really matter. You could have just kept it 5 over 2. I would have been fine with that. But the book writes it 2.5. And there you go. There's x and there's y. So if x is 4 and if y is 2.5, that'll make this thing into a parallelogram. We good? All right, let's do another one. Pretty easy stuff, I think. I hope you do. To another parallel. Well, again, we don't know it's a parallelogram just yet, do we? This will be the last one we do. Let's see. They tell... Actually, let's... Oops. Okay. Let's say that this is 56 degrees right here. Let's say this is 7x right here. Let's say this one is 5y minus 26. And this is 4y plus 4. Look, this is no more difficult than what we just did, I don't think. I think it might be even a little easier. I don't know this is a parallelogram, but it says solve for x and y so that you make that into a parallelogram. Okay, what must x and y be equal to so that this thing is a parallelogram? Well, I've got angles here, don't I? So what do you think I'm going to do to these angles to make this thing a parallelogram? I'm going to set them equal. Set which one's equal, though? The opposite, right. The opposite angles equal to each other. So let's do the x's. Okay, these two are opposite, right? So we just say 7x equals 56. So what's x? There it is. Easy as that. Pretty simple, right? What's that? What do you say? Oh, good job, Caitlin. Yes, congratulations, Caitlin. Very good. 5y minus 26 equals 4y plus 4. Everybody understand why we're making these equal to each other? Because they're opposite angles. If the opposite angles are equal, that makes this thing into a parallelogram. So let's do this. Subtract 4y from both sides. That's a y. Add a 26. That's a 30. And there you go. Easy as that. Wow. I was looking for something a little tougher than this, weren't you? Nah, not really. All right, well, that's it. That's section 6.3. Piece of cake. All right, let me give you some problems to do. I know you don't want to go away empty-handed, do you? So it's pages 414 and 415, and we're doing 9 to 23. It's not that bad. There it is right there. Make sure you put the section number, okay? Look, put the section number on your homework. Put the pages, put which numbers they are, and put your name on it too. That should be the first thing you always put on your homework. Is your name, the section number, and then the pages and the numbers you're going to do. All right, everybody good? All right. All right, you actually have some time to start working on this. Okay, you got about 10 minutes. So let's work on this. You can probably get a bunch of this done already before you even go home.